So here we're going to talk about random variables. So random variables represent a value associated with each outcome of a probability experiment. Okay? So random variable might be the worst named definition ever because it's not random and it's not even a variable. Okay? It's a function which assigns numerical values to the outcomes in the sample space. Okay? So like say you flip a coin. Right? So when you flip a coin, there's two outcomes. Either you get a heads or you get a tails. So what the random variable does, it's like a function, okay? It's like a function. So if x is a function, okay, so you're used to seeing like f of x, right? So instead of f being the function, we're going to say x is the function, okay? So x of the outcome heads, all right? When I plug that into my function, it maps it to the number 1/2. Now, why does it map it to the number 1/2? Because the probability of getting a heads is equal to 1/2. All right, that's the idea. So x also takes the tails idea and then it says, okay, it maps it to 1/2 there. Okay? So it's a function that takes an outcome like heads or tails, and then it says that outcome gets mapped to some number. That's the idea of a random variable. So you can have two types of random variables. The first type of random variable is a discrete. A discrete random variable, and since we say random variable so much for the rest of the class, I'm going to put RV for random variable. So random variable is going to be represented by RV. Okay? So a discrete is something that is finite or countable number of possible outcomes that can be, and here's a key word, listed. Listed. So an example of discrete, which is finite, say x is the random variable and it represents the number of heads shown when flipping a coin five times. So if I write out the whole sample space for the random variable, okay, if I flip a coin 5 times, I can either get 0 heads, 1 heads, 2 heads, 3 heads, 4 heads, or 5 heads. Notice how I can't get a half of a head. There's no way that you can get half heads, half tails, right? So it's 0, 1, 2, 3, 4, 5. Why did it stop at 5? Because we only flipped the coin 5 times. That's an example of something that's finite. It's limited to some number, okay? It's the opposite of infinite. Infinite means it goes on and on and on forever and ever, right? So countable is something that is infinite, but we can still put it in a list like what we did here. Okay, so how can I do something that's infinite? Say x represents the number of babies born in July. Okay, for the worldwide. So very rare scenario, you could have no babies born, right? Then you could have 1 baby, 2 baby, 3 baby. Man, that thing just keeps on going forever and ever, right? Theoretically, okay? So that number can get infinitely high, okay? So this is an idea of something that is countable, right? I can put it in a list, but there's infinitely many. Okay, that's the idea there. So those are two examples of discrete random variables. So let's do the other type. The other type of random variable is what's called a continuous random variable. Okay, continuous random variable has an uncountable number of possible outcomes, okay, represented by a number line. meaning like, so say we have x is going to represent the measure in inches, okay, of the heights of a person. So what's the smallest person? Well, when they're itty bitty in the womb, so they start out 0 inches. And then what's the tallest person? I don't know, maybe 8 feet, whatever. Okay, so 8 feet, so that's 8 times 12, 96, okay? And then you got average height, I don't know, maybe 5'8", I don't know, whatever. 5'10", so maybe that's like 68 inches, okay? Now, why is this a number line? Because you can be any height in between here and here. Why is this continuous, though, and not discrete? Because I can list this out, right? 0, 1, 2, all the way up to 96, right? But that's not all the numbers. There's even numbers between 0 and 1, aren't there? Okay? Well, what's between 0 and 1? 0.5? Is that the next number? No. You could have like 0.05, right? Is that the smallest number that's a little bit bigger than 0? No, you could have like 0.00005, right? Guys, you can continue this game forever and ever and ever and ever, and you'll never get the number that's right before 0. That's the idea of continuous. You can list the first one, and you can list intermediate ones, but you literally cannot get the next number after 0. That's why we use a number line to represent how tall all the measures. So this would be like the interval from 0 to 96 inches. If 96 was like the tallest person ever, okay? And you could never get any taller than that. This is interval notation. We use a bracket when we include the value, and we use a parentheses when we don't include the value. Okay, so it means we get really, really close to 0, but we never touch it. And this means we get really, really close to 96, but still stay a little bit less than it. Okay, another example you might run into would be like X represents the amount of gas in your truck tank. Okay, so how would we do this? How would we represent that with a number line? Maybe 0 is the least amount that you could have, and maybe 24 gallons is the most you can fit in your truck. So it would be from 0 to 24. Okay, so it's an interval. Right? You at some point, if you start at 24 and you go down, you work your way down to 0, technically there'll be some point where you have pi, which is like roughly 3.14, right? Pi gallons of gas in your tank. That's an irrational number. You can't write it as a fraction, okay? So meaning if you try to do a decimal approximation, you'll never get the exact value of pi. You'll only get an approximation, all right? So there's infinitely many digits that are connected to pi, all right? That's an idea of like a uncountable, right? That's an uncountable. That's the idea behind continuous random variable. So those are your two types of random variables that we're going to talk about in this course.